Okay, so now here's the next lesson. We're going to go ahead and do lesson 22.2. Please go ahead and copy the title and the essential question. Ready? Go. Now, to understand this lesson or this section, you have to know your vocabulary words. So go ahead and write down the definition for permutation, and then I'm going to explain what the fundamental counting principle is, okay? So there you go. Permutation is just different ways where you can list numbers or anything, okay? So for example, if you have only 3 letters, you can put them as ABC or ACB or BAC or BCA, CAB or CBA. And this shouldn't be a mysterious thing, okay? Since we have 3 letters, if I have A, what are the other 2 letters I could have? I could either have ABC, and if I have another A, the only other option is CB, right? And if I start with a B, what are the other options? I can have AC, or if I start with another B, CA, right? If I start with the C, I could have the option of putting AB, or I could start with C, and now this time I'm going to put BA. So obviously there's only 6 ways I can do this, right? Okay. So then really think about it. How did I figure out how many ways I can put them in different orders? There were 3 letters, 1, 2, 3, right? So the fundamental counting principle basically says, okay, there's 3, so you go 3 times 2 times 1. And that's 6, so that's how you got it, okay? But if you had A, B, C, D, it's going to be a little bit more complicated. But anyhow, we're just gonna just leave it like that. As far as the fundamental counting principle is concerned, we can talk about ice cream, all right? So let's talk about fundamental counting principle. It's just counting. Let's pretend that I go to an ice cream shop, but the rule at this ice cream shop is that you can have only 1 scoop of ice cream and you can only pick 1 flavor, okay? And then you can only pick 1 topping. That doesn't even make sense, but we're just pretending so I could help you understand what fundamental counting principle means, okay? So let's pick 4 flavors. Vanilla, not my favorite. Coffee, sometimes I like it. Chocolate is always my favorite. And then strawberry. I hate strawberry. I don't know if it tastes weird. Okay. Topping is sprinkles. Maybe Reese's Pieces. Maybe gummies, like a gummy bear. So we have 3 toppings and we have 4 flavors of ice cream, okay? So how many different kinds of ice cream can I get? Well, if I were to pick vanilla, I can only choose sprinkles, so that would be 1 kind of ice cream I can have. Or maybe I can have vanilla ice cream with Reese's Pieces, okay? Or maybe I can have vanilla ice cream with gummy bears. So how many different flavors, how many different kinds of ice creams can I make with just this vanilla flavor? Well, 3 different kinds, yeah? But the same thing goes for coffee as well. There's 3 different options, and for chocolate and for strawberry. So if you count all the different ways you can have your ice cream, there's actually 12. And how did you get that? There's 4 here, so it's 4 times 3. And that's how we get 12. And this is the fundamental counting principle. You're basically counting all the different ways you can make your ice cream. Okay? Kind of like arranging your ABC in different ways, all right? So now let's go back. Okay, so in order for us to calculate stuff, we need to understand what n factorial means, okay? And it is written like this, and that means that. And a lot of you are confused right here just because of the letter and all that stuff. But this is very simple. N factorial means, let's say we have something like a 4 factorial, and we just write it like this with the number 4 and an exclamation mark. That just means you start from 4 and then you multiply all the way down. 4 times 3 times 2 times 1, and that's 4 factorial. So then what's 7 factorial? Yes, 7 times 6 times 5 times 4 times 3 times 2 times 1. And that is what a factorial is. Okay? Now, before we continue on with the factorial, let's go ahead and solve a problem that we have over here in our textbook. Wait a minute, is it here? Oh no, it's the other one. So there you go. I have a problem here, and as you can see, I already did them, right? Okay. So there you go. This is the question that I want to work on. There are 8 members in a club, and each year the club elects a president, a vice president, and a treasurer. What is the number of permutations of all 8 members of the club? So right now they told us they elect a president, a vice president, and a treasurer, but they didn't give us any. They didn't ask us anything about that. They only asked us what is the different ways that all the 8 different members can be ordered. Okay, so then you can figure this out, right? There are 8 different ways to make the first selection, okay, and all that stuff. But you know what? Let's change the question a little bit, because when you go down here, they ask you the real question, which is how many different ways can the position be filled? Let's go back and remember how many members were in there in this club. Yes, there were 8 members, and the positions that has to be filled was president, vice president, and treasurer. Ooh, Treasurer. What's wrong with me? I can't spell. So anyway, so using that information, let's try and answer this question and not that other one. Okay? So you need to fill 3 positions, and let's say that we have 8 members, and I'm gonna use alphabets, and let's pretend that those are the alphabets of everybody's last names. Okay? A, B, C, D, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then we have 8 members with all these different last names. And so when I want to pick a president, and we're assuming that everybody is qualified, how many people can I pick out of if I wanted to pick a president? Yeah, I have 8 choices, right? Okay, so I had 8 choices for a president. Let's say that B became the president. Now, because the person with the last name B, let's call it Banuelos, okay? It's the president, so the president cannot also be elected as the vice president, right? So now we cannot pick the B. So now we're done with the president. We're looking for the vice president. So how many options do I have? Yes, 1, 2, 3, 4, 5, 6, 7. So now I have 7 options for the vice president. Now let's say that G was elected. What would be a good last name for G? Garcia was elected as the vice president, right? So now we want to elect our treasurer. So how many people do we have left? We cannot pick the president and the vice president to be the treasurer, right? So we have to use pick from one of these. 1, 2, 3, 4, 5, 6. Now we only have 6 people left, right? Okay, so then there you go. In how many different ways can the position be filled? Now we're trying to answer this question right here. The answer is 8 times 7 times 6, which is 336. Okay? And so this is really cool because you are basically using the fundamental counting principle to figure out how many different ways the position can be filled. So let's go ahead and check our answer. There are 8 different ways to select the president. We already talked about this. And then 7 different ways to select the vice president. And then 6 different ways to select the treasurer. So you can check that answer. And so then obviously I already checked this before I started my recording. So how many different ways can the position be filled? 336. So let's go back, because we're talking about how B and G and then somebody else got elected, right? So there are many different ways that you can actually write the 36 options. It could be A, B, C, the president, vice president, treasurer. It could be A, B, D, A, B, E, A, B, F, A, B, G, and A, B, H. Now you can see just with the president and the vice president being A for Aguilar and B for Banuelos, we still have many different options. 1, 2, 3, 4, 5, 6 options that we have for the treasurer, right? So, I mean, I'm mumbling here, but I hope you get it. This is how you do that, okay? So now let's move on. This is where they talk about the probability, okay? So permutations are the number of permutations of n objects taken r at a time is given by. And so this is something that you actually do have to write down, okay? So we talked about factorial already. So please write this down, because this is the formula we need now, okay? So then you're like, oh my goodness, Miss Choi, what the heck is all this? Okay, so let me go ahead and make it very simple for you, because there's a question coming up soon. Permutation, the P stands for, oh, it's a permutation. Because I told you today in class, there is a difference between permutations and combinations. Permutations means the order is important. For example, ABC and CBA is very different because the order is different. Okay, but for example, if you have MMM, then whether you switch those two M's or whether you switch these two M's, the order is not important, right? So in this situation, we call it combinations. In this situations where the order is different because it looks different, we call it permutations. So that is all you have to remember. And the formula for permutations is this right here, okay? So what does the N and the R mean? That means out of N. So remember the president, vice president, and the treasurer thing that we were working on? How many people did we have over there? Well, we had 8 people total, and it was a permutation because the order of the president, vice president, and treasurer was important, right? But out of that, how many people were we selecting to become officers? Well, there were only 3 positions, and that was president, vice president, and treasurer, okay? So then we actually calculated, it was like 8 times 7 times 6, right? But there was a formula for that, okay? And so what is the formula? It's n factorial. N factorial was this, right? So it's going to be 8 factorial on top. And then down here is going to be n minus r. So 8 minus 3 factorial. So let me see if we still get the same answer, 336, using this, okay? 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2. Let's pretend that's a 2 times 1. And I'm not going to write the 1 because I can't go there. I don't know why. And what is 8 minus 3? That's 5. So what's 5 factorial? 5 times 4 times 3 times 2 times 1. Okay, so then obviously, because this is a number divided by another number, we can actually simplify it, can't we? Yes, we can. Okay. So 5 and 5 can be canceled out. 4 and 4 can be canceled out. 3 and 3 can be canceled out. 2 and 2 can be canceled out. And obviously 1 doesn't count for anything. Oh no! So what are we left with? Is this exactly the same thing as we did earlier? We're just left with 8 times 7 times 6. And what was the answer for that one anyway? It was 336. Okay, so see, instead of us trying to wreck our brain, trying to figure out how many different ways we can have the president and the vice president and the treasurer, now we can easily decide that there are 336 different ways of having a president, a vice president, and a treasurer, thanks to our formula. Ta-da! Isn't this amazing? So it's really important you write this down. Make sure you copy this, okay? Ready? Go. So then now, I'm not going to do all these questions, okay? I'm gonna go straight because Mr. Berger has this awesome video and you should watch it. But I'm gonna go straight to your homework problem, Okay, and so this is probably going to be different from the one you have. Okay, it's the exact same question, but they have different numbers, as you can see. All right, so now here's the question I want you to copy. There are 8 finalists in the 100-meter dash. Oh, how many finalists? 8 finalists, okay. Suppose 3 of the finalists are from United States. Okay, 3 of them are from United States. Because you know the Olympic Games, there's not just people from United States. We have people from Korea, my home country, or from China or Mexico or Guatemala, or I don't know what else is down there. I need to learn my geography again. Anyway, and there's also different countries, but you know, I'm just trying to think of the countries that maybe we came from. Spain, where else? Germany, France. Okay, anyhow. So then, what is the probability that the United States will win no medals in this event? No medals. Okay, so let's try and figure this out, okay? There are 8 finalists, and out of the 8 finalists, how many are we picking? Out of the 8, we're going to be picking, and order is important, so we use permutation P, right? We're picking 3, okay? And so that is the probability of anybody. It could be anybody, any of the 8 people winning the medals. Because how many medals do you have? Don't you have a gold medal, and then a silver medal, and then a bronze medal? Okay, so unless I'm crazy, I know that there's only 3 different kinds of medals you can get. So right now, what we're trying to do is, how many different ways can any of the 8 people, whether they're from United States or not, it doesn't matter, how many different ways can they get the medal, right? And so this is the same thing as we just did earlier. Okay, so it's going to be 8 factorial over 8 minus 3 factorial. Why was that? Because of the formula, right? And so basically that's 8 factorial divided by 5 factorial, and we all know that the answer is 8 times 7 times 6, and that's 336. Okay? And so that is many different ways that any 3 people can win the medal. Okay? Because right now we're looking for the probability, so we first need the universal set. And so this is the universal set, right? So now out of here, this time they're asking us, what is the probability that the United States will win no medals? So now we're going to create a new set. And in that set, United States wins no medals at all, okay? So there are 3 people from United States. But out of United States, how many people are going to be able to win the medal? Nobody. And so nobody is 0, right? Okay, so we're talking about United States not being able to win any medal at all. So what will be the probability that all 3 of them win nothing? Well, out of 3, we're picking 0, and that kind of sort of doesn't make sense. And so you know what we're going to do? We're going to basically say, oh, if United States is not going to win any medals, what does that mean? Well, the 3 medals are going to be selected among who? Out of the people who are not from United States, right? So if 3 people out of the 8 are from United States, how many people are not from United States? 8 minus 3. Yes, there's 5 people who are not from United States. So that means all 3 medals, the gold, silver, and bronze, will be won by what? The 5 people who are not from United States. Because it says that is the probability. What is the probability that the United States will win no medals? Okay? So then that basically means everybody from outside of United States, the 5 of them, won all the medals. Okay, so what would be the probability of that? What will be the permutation for that? Well, 5 factorial over 5 minus 3 factorial. So that would be 5 factorial over, that's an exclamation mark, 2 factorial, okay? So that's 5 times 4 times 3 times 2 times 1 over 2 times 1. Okay, So what is our answer? 5 times 4 is 20. 20 times 3 is 60. Ah, okay. So then, out of all possibilities, 336, that's the universal set. The probability, okay, the chance that United States will win no medals is basically the other 5 people winning the 3 medals, right? That would be what? 60. Okay. And so then we're not done yet because we can simplify, right? So let's go ahead and simplify. I think we can divide the top and the bottom by 6, right? So 60 divided by 6 is 10. 336 divided by 6 is 56. Oh, we can still divide further. Let's divide top and bottom by 2. So that will be 5 and 28. So what is your answer? The probability of the United States winning no medals is 5 over 28. Okay? So then, that's it. Okay, so what I did was I checked my answer in the previous page and I was right, okay? So what we're gonna do now is learn the next concept, which is finding the numbers of permutations with repetition. Okay, so for example, let's take a look over here. Here are permutations of the letters A, B, and C. Then you scroll down. And next here are permutations for M, O, and M. So look, some of them are repeating, so it's kind of weird. This pink M and this blue M, we switched it around, right? You can see this M and this M are 2 different M's, and they switched the order around. But when you look at it, it still spells mom. What about these 2 M's? We switched it around, but they still spell what? Mo. And what about these 2 M's? We switched them. Okay, we actually moved them, but it still spells like okay, so there are some repetitions, and when we have repetitions, we use a different kind of a formula. So that's what we're going to look at. And let me see if the formula is shown to you right here. Yeah, if you don't see the color, you can see they all look the same, right? Mom, mom, mo, mo, Okay. So what is the formula in a situation like this? That should be our next question. It's right here. Ooh, and I wish I can bring this a little bit this way so you can see. Oh, there you go. This is the formula, okay? So go ahead and write this down. First, write this down because that's the formula. Whenever we have permutations where order is important, okay, but then we have the same letter or something like that, so there's like a repetition. So when that kind of thing happens, we need to use a different formula. And so it would look like this. A good example would be the next question that you see down here. And what I'm going to do is I'm going to just try and solve this over here. You can scroll down and see it, but I'll just do it. So let's see. This is a permutation with repetitions, okay? So Missouri, it says how many different permutations can be formed using all of the letters in this word? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 letters in there, so that would be N. So we'll put 8 factorial over there. And then A and B and C and D, those are basically the letters that are repeating. So then now that we know that we have a total of 8 letters, let's see how many repeating letters we have. Guess what? We have 2 I's. So that means we have to put 2 factorial. The A would be the I, okay? What else do we have? Oh, I see that there are 2 S's, so we have to put another 2 factorial. Is there anything else that's repeating? SS, II? Nope, nothing else, okay? So in how many different ways can we, move the letters around and make sure that they look different? You just have to solve this. So 8 times 7, 6, 5, 4, 3, times, okay? Times 2 times 1. Over 2 times 1, okay, times 2 times 1. So then, of course, the 2 and the 1 cancel out. The 2 and the 1, 2 goes into 4 2 times. So what would your answer be? 8 times, 7 times, 6 times, 5 times, 2 times 3. And yeah, I'm pretty bright, obviously. But all those big numbers are difficult for me to calculate too. So you can just go ahead and use your calculator. There's nothing wrong about that. And your answer is? Your answer is 10,080. So we have 10,080 different ways of switching the letters in the word Missouri. And so there could be many different words. If all of them made sense, that would be cool. But nope, I don't think anything makes sense. So anyhow, let's check our answer. That was 10,080, right? Okay, so there's 8 letters, 2 S's and 2 I's, right? And so that's the formula. And yes, we were right, okay? So in that way, you can solve all this, but you can study this on your own. So what's the whole point of me going over this with you, right? So let's do your turn question, okay? What I'm gonna do is I'm gonna go ahead and pick some other example. So mine looks different from your turn questions, right? Okay. So now there you go. I'm gonna go ahead and use this one. Okay. This is my your turn question. You have the same one, but probably they're not gonna ask you about Montana, something else, okay? So how many different permutations can be formed using all the letters in Montana? That means how many different ways you can make words that don't even make sense using the letters in here, okay? How many magical words can you create using the letters in Montana, right? So let's see. 1, 2, 3, 4, 5, 6, 7. We have 7 different letters in there. And then how many of them are repetitions? Well, let's take a look. We have 2 N's, right? So that'll be 2 factorial. And then we have, 2 A's, and that's it. So this is just like the other question. Oh, I must have selected the wrong kind. Anyway, so 7 times 6 times 5 times 4 times 3 times 2 times 1 on top, because that's what 7 factorial means. And at the bottom is 2 times 1 times 2 times 1. Cancel out. This becomes a 2. So let's calculate again using a calculator. And you get 1,260. That was too easy, huh? Okay, so let's check our answer. Is it 1,260? Let's see. Check answer. Yay, it says correct. Okay, so that was correct. All right, and that's it. Let me see what the next example is. Well, this is the same thing, okay? There's 1, 2, 3, 4, 5, 6, 7 numbers, so 7 factorial on top, but then there's 3 5s, 2 1s, and 2 2s. So really quickly, let me just show you the formula. There's 1, 2, 3, 4, 5, 6, 7 numbers, so it's 7 factorial on top, and then there's 3 5s, so that's 3 factorial, times, there's 2 1s, so that's 2 factorial, and then there's 2 2s, so there's another 2 factorial. And so when you calculate this, you'll get the correct answer. Ooh, are we almost done now? I've been recording for a while. There is another concept. Let's see what this is. Okay, so this one is where they make it a little bit difficult for you. Okay, so what I'm going to do is I'm going to leave this part alone because I want you to go ahead and try and work on these in the classroom, this last concept. Let me see if the questions show up on its own. Okay, I think it's going to take a while. So you know what? I'm just going to stop here because what I want you to do is concept 4 and the section where you evaluate. I want you to go ahead and do those in the classroom. Usually I only want you to do the evaluate in the classroom, but today, because I've been recording for so long, 30 minutes now already, I'm gonna have you just wait on this one. We could go ahead and do this in the classroom together. I'll give you 2 challenge questions in class, okay? All right, so I hope now you feel like the lesson is easy. Okay? Well, thank you so much. Have a great day.